All right, welcome. Today we're going to be talking about addition of fractions. Now, to start out with, we're going to be adding fractions with common denominators and then moving into fractions that have uncommon denominators. Now, the addition of subtraction of fractions really is about the same. So once you get 3.5 of addition figured out, 3.6 is going to be pretty much the same. So I'll leave you to read this on your own. But essentially what we're doing is we want to make the same size pieces. And so if you think of a fraction here, we have 2/6. We've been talking about fractions already by parts of a whole. So if I have a whole rectangle and I split it up into 6 pieces and I shade in 2 of them, then this rectangle could be represented with the fraction 2/6, or vice versa. 2/6 could be this rectangle. And over here you can see we have the same whole amount, and it's broken up into 6 pieces. So once again, we have sixths, and in this case, we have 3 of them. Now, if we combine these two, I would have 2/6 plus 3/6 makes 5/6. 5 out of the 6 are shaded. So let's go ahead and do a couple of these together. I don't know that we'll do them all, but to start out with, we've got 1/4, and so we'll make here's going to be our whole amount, and then we'll say 1/4. That means we've got to split this up into 4 equal parts. We're pretty close to equal. 1, 2, 3. So 3 lines, we'll turn it into 4 parts. 1/4 would be just this. Right? 2/4 would be 2 of these shaded. There's 2 of them. And so then if I put those together, and this last little bit over here, if I have 1/4 plus 2/4, of course that would make 1, 2, 3/4 would be shaded. Our equation then would be 1/4 plus 2/4 equals 3/4. Notice that this down here stays the same. 1/4 plus 2/4 makes 3/4. That fourth down there, you can almost think of it like a label, right? Like if I had 1 apple plus 2 apples makes 3 apples. Well, 1/4 plus 2/4 makes 3/4. Right? Down here, if I have, if I'm doing the same thing, but I'm doing it with fifths, we'll put our wholes on here. And then for fifths, I've got 1, 2, 3, 4 lines will make 5 boxes, right? 1, 2, 3, 4, 5. There we go. So 3/5, I've got 1, 2, 3/5, and I'm going to add to that 4/5. 1, 2, 3, 4/5. And if I try to do all that over here, look, I've got 1, 2, 3, so there's my 1, 2, 3, and I've got to put 4 more in, right? So if I put 1, 2, that's only 2 out of them. It turns out I need another whole amount so that I can break it up into the appropriate pieces, into the same size pieces. There, now I've already shaded in 2 of them, and I still need 2 more to get to the 4. There. Now you can see I've got 1, 2, 3. That's for this part here. And I've got 1, 2, 3, 4 more, and that's for this part here. So what I could say is 3/5 plus 4/5 makes a total of, if I count them all up, I have 7. But remember, my label is fifths. Right? That denominator down here, it's not going to change. It just stays the same. 7/5. Okay? All right. Oh, for some reason, jumping around a little bit. There we go. All right, so if I want to do 2/3 plus 4/3, now some of you guys have probably already noticed our little pattern, or you might even know how fractions work, and that is if you have common denominators, you treat it just like you would treat a label. 2/3 plus 4/3, 2 plus 4 makes 6/3. And of course 6/3, 6 divided by 3 is just 2. if we want to do that with our pictures, it'll look something like this. We'll put this here, and we already know I'm going to need 2 of these. You might not have known that, but we do now. So if I have 2/3, and then, oops, I actually need a whole nother one over here because I need 4/3. So we'll put that in here. There we go. Now, if I want 4/3, here's 1, 2, 3, 4/3. And if I add all those up, you know I'm going to get 6/3. And ultimately, that just ends up being 2. I get 2 whole pieces shaded, right? So common denominators means that all we have to do is just add the numerators. That's it. Okay? All right, let's move on to doing this a little bit quicker instead of having to draw this out each time. And it's just what we were talking about, where if you have a common denominator, then you keep the common denominator and you just add the numerator. 2/7 plus 3/7 makes 5/7. Right? 1/8 plus 5/8 makes 6/8. The denominator stays the same every single time, as long as you have common denominators. And then you just add the numerators. Okay, don't forget to reduce. So looking down here, this is where we're going to start to just do this a little bit quicker. 5/10 plus 6/10. Notice that we have common denominators with our tenths. So I can keep that denominator the same and then just say 5 plus 6 makes 11. And then we're done. 19ths, okay, cool. 7 plus 3 makes 10 19ths. You have a common denominator, the denominator stays the same. 3 plus 9 plus 1 makes 13 15ths. Okay. Of course, common denominator, I get 6 plus 7 plus 3. You know what? I'm going to actually put these two together first. I'm going to use the associative property of addition, and I'm going to choose to add together the back ones first. I'm going to do this like this. 7 plus 3 makes 10, and now I can do 6 plus 10 makes 16. Of course, 8 does go into 16 2 whole times, so that will reduce down. None of these other ones, I didn't talk about them, but none of these other ones reduce any, so that's why we didn't, because there was no common factors with the numerator and the denominator. Okay. All right, let's look at a word problem on where you might run into something like this. And that is to say that, so Nate bought 3/4 pounds of Gala apples and 3/4 pounds of Granny Smith apples. How many total pounds did Nathan buy? So we're going to add 3/4 plus 3/4. And the thing to remember here is our highlighter shows us we have common denominators. If we have common denominators, that stays the same. It's just like a label. Okay. 3 plus 3 makes 6. 6/4. Now 6/4, I know that 2 goes into both of those. I could say like divided by 2, and that's going to then make 3 halves. 3 halves pounds apples. Now that's a good answer, but you know, we don't usually talk like that. Like math teachers love this answer because, well, I mean, I love improper fractions. But if we actually put that into a mixed number, I would do it something like this. 3 divided by 2, 3 halves. 2 goes into 3 one time with 1 left over. That means I have 1 whole time and a half left over. So 1.5 pounds of apples. Okay, just as a reminder, this 1 right here ends up going up into the numerator, whereas this is that big 1 there. And then obviously the 2 here, obviously that's going to be your denominator of their fraction. Okay.